The graph f prime of x, the derivative of f of x, is shown to the right. Which of the following statements must be true? Interesting. So one of the key points here is must be true as opposed to might be true. Okay, so we have the graph of f of x. So here is f prime of x. I think I'll use a different shade of blue. There we go. The graph f of x has a relative minimum at x equals -3. 1, 2, 3. Okay, so this is the slope. So the slope of f of x, I'm going to draw a possible representation, though poor representation. Poor representation of f of x. So for f of x, the slope goes, this -3, goes down, and then it goes up. So you have a negative slope here, less than -3, followed by a positive slope. So, yes, there is a relative minimum at x equals -3, because you get this downward slope, followed by an upward slope. Okay? Number 2, the graph of f of x has an inflection point. Okay, so an inflection point is when the second derivative equals 0. At x equals 0. Or x equals 2. Okay. So what this is saying is here. So what happens here is you have a positive slope followed by a negative slope. So when it's crossing the x-axis here, what you're actually getting is a local maximum, which isn't an inflection point. An inflection point is a change in concavity. So you get something that looks kind of like this. So that's a little extreme. There we go. Something like this. And the way I look at concavity is if it's able to hold water. So if you had water coming down here, this would be concave down, would not hold water. But down here, you would get water pooling. So that would be concave up. And the inflection point, which is probably somewhere right around there, is when you have a change in concavity from concave up, concave down. Or to say it another way, goes from holding water to not holding water. And inflection points happen when f prime prime of x equals 0. So it'd be right there would be an inflection point, because the slope of the derivative would be 0. F prime prime of x is 0. So the inflection point would be there at x equals 0, not x equals 2. And you can kind of see that based on what you know from the first question. So if you understand the first question and understand why the number 1 is true, you'd probably also understand why number 2 is false, because they're talking about similar points. They're talking about when you cross the x-axis. Okay? So I'm going to make a dash. The graph of f of x is concave down for 0 less than x less than or equal -4. So, okay, so it's talking about this area right here. 1, 2, 3, 4. Yes. So concavity is the second derivative of x. We have the first derivative of x. So if we look at the derivative of the first derivative, we will get the second derivative. And when you're looking at the derivative, f prime of x, what you're really looking at is slope. So what we have here is the f prime of x has a negative slope. It's sloping downward. Therefore, f prime prime of x will be less than 0 for this portion right here. 0 less than x less than or equal to 4. Because it still seems to be going down at 4. But, yeah, okay, that makes sense. And so, yes, that will be true. Whoop. So we have 1 and 3 are true, but 2 is false. And the reason 3 is true, graph of x is concave down, is because we're given f prime of x, and we're trying to imagine what the f prime prime of x will be. which is the same as taking one more derivative. So that's therefore looking at the slope of f prime of x. I know there's a lot of words involved there. A lot of them sound similar, and it is difficult to keep track of. But that will be true. So 1 and 3 will be true, but 2 is not. And that is how you look at this kind of problem.